Hi guys, Mrs. Delisin here. Welcome to another lesson of AP Statistics. We've already learned how to do a completely randomized design. We learned that one on the previous lesson. So today I'm going to give you another example of a completely randomized design. And then from there, we're going to move on to another designs of experimental study. So high school decided to offer an SAT prep class again this year. It will be offered in two different formats, online or classroom teacher. The counselor wanted to know which teaching method will yield higher SAT scores, so they have allowed us to set up an experiment. 50 students have signed up to take some form of the SAT prep class. There are 20 seniors and 30 juniors. So please note that all of these 50 students, they wanted to be on an SAT prep class. But at this point, they don't know if they're going to be assigned to an online prep class or the classroom teacher prep class. Now outline a completely randomized design to compare the two treatments. So since we have two groups, um, we have online and classroom. We are going to divide our 50 students, randomly assign them to group one and group two. Now at this point, I don't care if they're a junior or a senior. As a whole, all 50 students will be randomly assigned to one of the groups. So we have 25 for group one and we have 25 for group two. Now we have group one for online prep course and we have a group two for teacher prep course. And then after that, we compare SAT scores. I would like you to make to notice in here that we didn't care if group one was a senior or a junior. We're just grouping them as is. Now, that is called a completely randomized design. For number two, the counselors at the school hypothesized that the online versus classroom results could be greatly affected by the grade level of students that were put into each treatment group. They know that seniors generally score better on the SAT than juniors. That how could we adjust our experiment to ensure that there is an even split of seniors and juniors in each class? That we are going to draw an outline of the experiment with your modification. So for number one, we have 50 students, regardless of if they're a junior and a senior, and then we split them into two groups, right? But we are going to modify our experiment into making sure that we are comparing the result of a juniors and seniors. So you know how in a observational world we have something called stratified random sampling. In experimental world we have something called the block design. So what is a block design? A block design is, and remember, this is like really close to what stratified is. You know how stratified we group them: all females, all males, all juniors, all seniors, and we get samples from there. So sometimes a lot of students will call this strata, but this is not a strata because this is not an in the world of observational study. We are now in the world of experimental study, and so we don't call that strata, we call it block, right? So our block is the grade level. So instead of having all 50 split them into two groups, we're now we split them into seniors and then juniors, and then each of those, the group of seniors will be split into two groups of online and teacher, right? And then the 30 juniors will split the 30 juniors, so of course 15 and 15 into two groups, and we call that 1B and 2B. And then we give 1B the online prep course and then the 2B the teacher prep course. And then first we compare, of course, the SAT score of the seniors first, right? And then we compare the juniors, and then we compare by combining both of our results right after. So technically, group two is just a complicated version of group one. of number one. I mean, number two is just a complicated version of number one. The advantage, though, of using number two is that you now have a better idea of how the seniors and juniors, right, of how their SAT scores were after the split. Okay, does that make sense? So again, now we learn two things. We have a completely randomized design and a block design. And then we're going to learn one more in number three. Now, the counselors are now worried that a student's GPA is certainly going to affect their SAT score. Let's look only at the juniors. We want to be sure that the different GPAs are being evenly distributed in the two treatment groups. How could we be sure that the GPAs are evenly distributed? Okay, so here's the idea. You know how we split all the juniors into group one and group two? Does that make sense? So we have group 1B and group 2B. Now they're worried that what if I know this is a completely randomized assignment. This is like a random assignment. So we don't really know who's in group 1B and who's in group 2B. We're grouping them regardless of their grades. Now, what if all the students that are in group B, the one that are taking online prep course, what if they happen to be all the kids that have 4.0 GPA, 3.8 GPA? Does that make sense? And then all the people, all the students that are in group 2B happens to be the kids that are struggling, right? So how can we be sure that group 1B didn't have a higher SAT score just because is it now because of their because a lot of kids there have a higher GPA, or is it really because of the online prep course? So in order for us to avoid that, we need to make sure that the kids that are higher GPA are evenly distributed into groups, in group 1B and group 2B. Does that make sense? All right, so how are we going to do this? Now, we put the 30 juniors. Remember, we're just focusing on 30 juniors here. We put the 30 juniors in order from highest to lowest GPA. So we have 4.0 kids, 3.9, 3.8, blah, 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 right? So imagine that we're listing them from highest to lowest. And then, of course, the first two kids on the list, those are the first two highest kids that had highest GPA, right? Take two students with the highest GPA and pair them. Now you flip. So let's say number one and number two. Both of these kids, number one and two, they both have higher GPA, highest GPA. We flip a coin to assign one of the student to the online class and one of the student to the teacher class. Repeat this process with the next two highest GPAs until all 30 juniors are assigned, or technically until all 15 pairs of students are assigned. So technically, the last two students in the list, these are the last two students with a very low GPA. And in this kind of example or situation, we're making sure that you know how the lowest kids, not I'm not gonna say lowest kids, the kids with lowest GPA, we are now making sure that they are evenly distributed to two groups. Is that making sense to you guys? This is called the match pair design. Okay? Good. We'll have more example of match pair designs later on. Now, here is our important ideas. Block is the same as strata, but strata is in the observational study, and then block is on the experimental study. Now, group of experimental units that are similar. It could be by gender, by grade level, by the state where they live, by their age group, right? So we could have it older and then young adults. It could be by buildings where if there are on the west side, east side buildings. It could be anything as long as they are similar to the group. Okay, randomized block design. This you have separate subjects into blocks and then randomly assign treatments within each block. And then match pairs design. The subjects are paired and then randomly assigned to a treatment. And then each subject received two treatments. The order of the treatments must be randomized. Okay, there is also there are two kinds of a match pairs design. The first match pairs design that we have is that the GPA one, right? Where one kid, the first two highest kids gets into group one and then the other one in group two. There's also another match pairs design where each of the subject, and I want you to get familiar with this, where each of the subject receive true treatments. For example, you wanted to know which one is better between the two drink, the Coke or the Coca-Cola or the Pepsi. Okay, I'm not so familiar. I don't drink cola. So Coke or Pepsi, for example, and you want to do an experiment of which kids or which type of drink students prefer, right? So in order for them to do that, you would have to give both of the drink to the kid, correct? So you're gonna have the kid, okay, you try this cup A and then you drink cup B. Which one do you prefer, right? So the person, the student, the experimental unit, the subject, I'm naming that different things, but this is the same. The subject is receiving two of the treatments. Does that make sense? That is also a match pairs design. Okay, then moving on. A political strategist would like to design an experiment to compare the effectiveness of a three different YouTube ads promoting a specific presidential candidate. She will use 300 randomly selected YouTube users for the experiment. YouTube users. Okay, 300 randomly selected YouTube users. So when we say YouTube users, it could be ranging from kids use YouTube, right? From kids, young adults, old people, right? And when we go to YouTube, we look at different things, right? So if I am more into educational videos, so I might be in YouTube for educational purposes, while kids might be in there for game purposes. So we go to YouTube depending on our age, we have different needs, right? So describe a completely randomized design to compare the effectiveness of the three ads. So technically, a completely randomized is just 300 subjects and then group them into group one, group two, group three, as simple as that. And group one will get add one, group two will get the add two, and then we'll compare the effectiveness. Okay, this is just a completely randomized design, very simple design. Now, describe a randomized block design for this experiment. Remember, when we do a block experiment, we're grouping them into groups that are similar. So we could group them by age, by gender, by level, by by block where they live, right? I have mentioned that earlier. So in this case, you have to think on your own which block design, right? Which block or which group would benefit more depending on the situation. So in this case, I would group them by the age group. So we have older people and we have younger people. Now, we don't know how old the YouTube users were in the sample, but we could maybe later on put numbers to it. Okay, so what is old? Maybe from 50 and above, and then we have 50 and below, we're gonna put it on the younger side. Or either way. And because this is a presidential candidate, so of course we don't care about kids at this point, right? Because kids don't vote. So technically we have this from 18 to maybe 18 and late 30s, and then all the way above are the what we call the old people. So in here we have 300 subjects. We group them into older 150, younger 150, and then the older folks we randomly assign them to three different groups, of course, because we have three different ads. And then for the younger one, we also have to group them into three different groups. Okay? And then we'll compare the effectiveness of our ads. Does that make sense, you guys? Okay? Why might a randomized block design preferable in this context? So why is it, why is number two better than number one? Technically, that's what is asking. So why is it important that we group these people from older generation to younger generation? Right? So the black design helps us to control age as a confounding variable. So within each block, there may be lower variability of results, making it easier to determine which ad is most effective. So in a short version of this answer is that of course, older people and younger people prefer different YouTube, right? They go to YouTube for different purposes, and so they prefer different types of ad. Now we don't have information of what this ad is. Maybe it could be a video, it could be a song, or it could be or a graphic. We don't know, but we're trying to compare. We're only looking at how are we going to compare them, and then how do we group the 300 subjects that we have. Okay, I hope that this video is not confusing to you, and if you have any questions, please let me know as soon as you can. And that's it. I will see you on the next video. Thank you, guys.